Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about factors which affecting vibrational frequencies in infrared spectroscopy. You know, I have already uploaded 2 and 3 videos based on infrared spectroscopy. So I would suggest please go through my previous video so that you can easily understand all parts of infrared spectroscopy. Anyhow, we will learn in this video factor affecting vibrational frequencies in infrared spectroscopy. My friend, the value of absorption frequency is shifted if the force constant of bond changes with its electronic structure. You also make your concept like frequency shifts also takes place on working with the same substance in different states like solids, liquids and vapor. The third important point related to factor affecting vibration frequencies is a substance usually absorbed at higher frequency in a vapor state as compared to liquid and solid states. So, factors responsible for shifting the vibrational frequencies from their normal values. Coupled vibration, Fermi resonance, electronic effects, and hydrogen bonding. I repeat, coupled vibrations, Fermi resonance, electronic effects, hydrogen bonding. So what is coupled vibrations? An isolated CH bond has only one stretching vibrational frequency, whereas methylene group shows two stretching vibrations, symmetrical and asymmetrical. I repeat, an isolated CH bond has only one stretching vibrational frequency, whereas methylene group shows two stretching vibrations, symmetrical and asymmetrical. Because of mechanical coupling or interactions between CH stretching vibrations in the CH2 groups, asymmetric vibrations occurs at higher frequency or wave number than symmetric stretching vibration. My friend, these are known as coupled vibration because these vibrations occur at different frequency than that required for an isolated CH stretching. So, a strong vibrational coupling is present in carboxylic acid anhydrides in which symmetrical and asymmetrical stretching vibration appear in the region 1720 to 1825. 1720 to 1825 inverse centimeter or centimeter. You can see here symmetric stretching and asymmetric stretching. The interaction is very effective probably because of the partial double bond character in the carbonyl oxygen bonds due to resonance, which also keep the system planar for effective coupling. Asymmetrical stretching band in acyclic anhydride is more intense, whereas symmetrical stretching band is more intense in cyclic anhydrides. So my friends, the requirements for interactions to occur, the vibrations must be of the same symmetry species. There must be a common atom between the groups of a strong coupling between stretching vibration. Second point. The third point is for coupling of bending vibration, a common bond is necessary. Interaction is greatest when coupled groups absorb individually near the same frequency. My friend, coupling is negligible when groups are separated by one or more carbon atoms and the vibrations are mutually perpendicular. Now, the important factor is Fermi resonance. What is this? Resonance, a vibrations of large amplitude produced by a relatively small vibrations. What coupling of two fundamental vibration mode produces two new modes of vibration. Just remember, coupling of two fundamental, I am talking about coupling of two fundamental vibrations modes produce two new modes of vibration with frequencies higher and lower than the absorbed in absence of interactions. Interactions can also take place between fundamental vibrations and overtone or combination tone vibrations, and such interactions are known as Fermi resonance. So, if two different vibrational level belonging to the same species have nearly the same energy, a mutual perturbations of energy may occur. Shifting of one towards lower and other towards higher frequency occurs. A substantial increase in the intensity of respective band occurs. So my friend, in this, a molecule transfers its energy from fundamental vibration level to overtone or combination tone level and back. So resonance pushes the two levels apart and mixes their character. Consequently, each level has partially fundamental and partially overtone or combination tone character. So you can see in carbon dioxide, asymmetric stretching and symmetric stretching. Dipole moment is zero. For example, symmetrical stretching vibration of CO2 in Raman spectra shows band at 1337 inverse centimeter. The two bending vibrations are equivalent and absorbed at the same frequency of 667.3 inverse centimeter. The first overtone of this is 1334.6 inverse centimeter. Fermi resonance occurs. There is a mixture of 1337 and 1334 to give two bands at 1285 and 1388, which intensify ratio 1:0.9 respectively. So another factor is like hydrogen bond. It occurs in any system containing a proton donor groups XH and proton acceptor of the S orbital of proton can effectively overlap the pi orbital of the acceptor groups. The stronger the hydrogen bond, the longer the OH bond, the lower the vibration frequency, and broader and more intense will be the absorption band. The NH stretching frequency of amine are also affected by hydrogen bonding as that of the hydroxyl group, but frequency shift for amine are lesser than for hydroxyl compound. Because nitrogen is less electronegative than oxygen, so the hydrogen bonding in amine is weaker than that in hydroxy compounds. My friend, intermolecular hydrogen bond give rise to broad band, while intramolecular bond gives sharp and well-defined band. The inter and intramolecular hydrogen bonding can be distinguished by dilution. Intramolecular hydrogen bonding remains unaffected on dilution. As a result, the absorption band also remain unaffected, whereas in intermolecular, bonds are broken on dilution. As a result, there is a decrease in bonded OH absorptions. So friends, the strength of hydrogen bonding is also affected by ring strength, molecular geometry, and relative acidity and basicity of proton donor and acceptor groups. Now the next important point, electronic effect. Changes in absorption frequencies for a particular group take place when the substituents in the neighborhood of that particular groups are changed. So it includes inductive effect, mesomeric effect, and field effect. So from here I will discuss next this point in next video. If you like this video, then subscribe my channel. And this video is very beneficial for NET, GATE, and JAM students. So if you like this video, then share it in your friend circle so that your friend will be also benefited with this video. And at last, I would say thanks for watching.